So as usual, when dealing with noise-based things, let's go into VOPs instead of using the Wrangler. So I'm going to make a point VOP, like so. Drop it on down here. And we'll get back out of the point mode. And let's limit, like we were saying, to just the inside. So in here, we're going to have our points, positions as input, and we're going to move them somewhere, and we're going to have a point position as the output. So let's make a noise. Let's do a turbulent noise. And there it is. This will be of a 3D type. We want a 3D noise so we can move it in X, Y, and Z direction. We'll take the position here as the input. We can promote, usually I'd say promote the frequency just so we can go do it above. Promote that one and the amplitude because that'll be how much it is. And we'll basically just say whatever vector you make, add it to the original point. So we'll say the position plus our new vector is our new output. So apparently that's super strong. Also, let's use a simplex noise. And let's start pulling that amplitude back. It's super strong right now. So let's say something like 0.03, just a little bit. Also, our frequency is too high, or rather it's too low. I can't see anything. So actually, let's make it strong. Bring this up. Okay, that was starting to look good there. Maybe this is just too high. So the higher the frequency is, the smaller the actual details will be. And then, of course, the higher the amplitude is the more pronounced those details will be. So 16 is looking pretty good here. And again, as we, in the negative numbers here. So let's do something really low. Maybe just like that. All right, so we got some business going on here. Cool. Now we don't want to go in all these directions. I don't want it to go in the Z in particular. I want it to remain flat. I just kind of wanted to crumble it up around these sides here. So what we can do is we can go back into the point VOP and I can say, hey, set component, because it is a vector. So we can say set vector component of this guy, and I'll say knock out that Z. So Z is component 3, and so the fval doesn't have an input, so it's just going to use 0. So right off the bat, you can see it goes from that to that. So now it's got motion. It has a displacement in the X and Y instead. Okay, so we're limited to 0.03 right now because the higher I make it, we're getting a more interesting piece for sure, but now we're getting all this craziness here because these pieces are moving right by the surface, causing all that nonsense to happen. So what if there was a way, instead of just knocking out that Z direction, as we did in the point VOP there, what if there was a way to not have it move as far if we were close to the surface? So like, this row and this row maybe shouldn't move as much, but maybe we could let the pieces in here move more. Wouldn't that be interesting? So we can do that. There's a few ways we can do that, but the way I'm going to do now is maybe even before we divide it up, let's make an ISO offset and make an SDF out of this. The SDF, as you might recall, is basically going to store in it how far away from the surface are we at a given voxel. So the more voxels that we can give it here, the better it will look. I'm going to say give it something up like 100 maybe. We can try 100. I mean, we can't really go too high on this. So 200 will still be pretty fast. That's going to be 200 along this axis, but barely anything along this axis. So now we have a volume that at all these different voxels are saying how far away we are from the surface. So now if I go, let's sample those points, or rather let's sample that value into the point. So I'm going to say attribute from volume. We'll put it here, put that there. So now it's going to sample that, And let's sample it into something called, we'll call it depth. We don't need to be a vector. Let's just make it a size of 1. And now if we look at this, we see we have all these depth values. Negative numbers are when we're inside of the piece, which should be most of everything. Some of these things are technically outside of it just because of the volume is not precise. But we know that they're near the surface anyway, so we can still use that. So coming back in here, maybe instead of doing this vector set component business, I'm going to say, I'll move this over here, move this over here, move this over here. Let's get that attribute, which was called depth. So we just type depth in here. And let's remap it to some, we'll basically fit it into some range here to clamp it. So we'll make a fit right there. We'll feed that in to the value. So the fit's going to say, hey, are you between this number and this number? You're now between this and this. This is the one that's of interest to us. 0 is the surface. We just promoted this guy, and that'll be the deepest that it gets. The deeper it gets, the closer it will go from 0 to 1. And we'll essentially multiply that number by the vector that we just came up with from our 3D noise. Now, when we reach 1, we're basically saying, be the entire displacement that you calculated. When it's 0, it's don't be that displacement at all, because 0 times anything is 0. So with this promoted, I can go look at this and say, what value should this go down to in order for this to start working? So I'm going to say something like, or even better to help us debug this, whatever this is, let's actually pipe this into to the color. So there it is. So now we're going to get a sense of the whiter it is, the more it'll actually move. And you can see it both moving it and also coloring it. And as we predicted, the stuff near the surface isn't moving. I think actually a hybrid solution might have been the best. Let's turn this thing back on so it's still not moving towards the surface. And now we've got something nice. So now we can get more extreme with our amplitude. Because it's never going to disturb the surface because we're not allowing the surface to move. Cool. So that's all well and good for the inside. And remember, none of this is going to affect our sim anyway. So we can make this look like whatever we want. And although it looks like it's just acting on this one piece, really it's acting on everything. Every piece is going through the same treatment. And because the noise is being sampled by the position, everybody's being moved in the same way. We're not going to have two pieces next to each other that are having one noise push into the other one and this one's noise is pushing into the other one. Because the border between these two pieces, they have the same point position. So their lookup into that 3D noise will either push both of them this way or push both of them that way. So we don't have to worry about that. Remember, as we scrub here, we can take a look at the different pieces because each piece is being isolated by the frame number. And of course, if you wanted more resolution, we could simply just go back up to that bricker. I think this will be enough considering our distance and everything else. And we're certainly not going to want to keep that color around, so I'm just going to turn that back off. Now, we still have these flat edges along the main face of the piece, though, so that we're going to want to move around too. So probably the best way to work on these edges, I'm thinking is, let's just copy and paste this guy here and more or less do the same thing, but not have it be limited to just the inside pieces or limited to just where the depth is a certain amount. So we'll say this is small, big, and let's just straight up, get rid of this multiply. We're not going to need this anymore. We're not going to need any of this depth stuff here. So there we go. So for some reason it kind of went away there for a second, but it's back now. And yeah, let's go back to this turbulent noise. Bring the turbulence down a little bit. You can see like the higher it is, the more prone it is to kind of doubling back on itself. we go down to like 2, it's not so bad. So that looks pretty good. There's a little bit of it back there. We could probably solve that by maybe bringing the actual amplitude down a little bit. So now it's mostly gone. Before I even continue working on that, let's just bring everyone back on board here. So it looks pretty good. I see some, I'm gonna actually go back into this mode. I see some errors here. Honestly, you probably won't even see them when it's flat shaded. You won't see it anyway. But for the sake of this getting this completely right, let's bring the amplitude down maybe even more. The pieces themselves still look pretty good. But no, I'd say it's worth having this extra craziness and suffer a few little of those minor normals looking things. Again, they almost certainly won't end up showing up in the renders anyway. Great. So we've got our crazy looking piece here now. And let's go back into like some kind of semblance of sanity here. We'll want to let's make some normals on it. Let's get some nice looking normals here. We want, of course, mostly we're concerned with the outside. So I'm going to say, let's just make normals on the outside for a minute. Pretty low barrier. And as far as the normals on the inside go, we can just say, we have our inside stuff here. And remember, this is still using our updated inside. We can say, okay, that looks pretty good. You know, it's nice. It's kind of nice doing it this way because now we'll have some smooth areas, some jagged areas, depending on how sharp the changes are, it's kind of like what we would expect from broken ceramic or cement or whatever this ends up being.